blue, not green. Just
Ooh.
I didn't know that either.
Well, in some languages, blue and green have the same name.
Yeah, I was having this conversation the other day with not you, but
No,
I think we're live.
are we?
Yes, I think
I
so.
see. Yes, it is. We were talking about blue and green. Hello, everybody.
Hey, how are we doing? Oh wow, yeah, a little bit of a faff there, but we're all sorted, which is good.
Yep. So, hi everyone, welcome. Let's see who said hi in the chat. We've had Munso, we have Renda, we have Miranda. Hi, folks. It's great to see you, and everyone who hasn't said hi.
And Roderick has just popped in. Hello.
And Roderick, hello.
So today's stream is going to be mainly focused on geometry nodes. I've got an interesting thing I want to go through. Well, I think it's interesting. You'll just have to come along for the ride. So, yeah.
Now, Mikey,
yes.
I know nothing about geometry nodes, so I'm looking forward to this. So
awesome.
Yeah, we should probably do some housework before I ask the question. What's a geometry node?
We didn't do any housework. Anyway, so is there any housekeeping we need to do before we crack into geometry nodes tonight?
I would like to explain why the energy's a little weird. I am brain fried, and Mikey just woke up because he's had a very long day. I have been moving the netcode on the game I'm working on over to the Steam API, which is causing me all kinds of problems. It's really well written, but I didn't understand the order in which information comes in. So I was calling information that wasn't yet connected and causing all kinds of issues.
Wow.
I showed Mikey my Git commit notes. Mikey, can I read my Git commit notes real quick?
Yeah. AKA Jan's descent into madness.
This is 5 days of commit notes. So let's start over here. Just opening the repo. Open the repo. Very slow reason.
Well, you're nice.
Okay,
you're not fuzzy today, which is good. Although
I restarted my router earlier.
Nice.
Okay. Maybe fix the filter list in the lobby ish. Net fiddling. Actually, I meant this one. More net. Working on friend invites. Think I fixed friend invites. No, I didn't. Lobby bugs. More bugs. Even more.
Now, before you carry on, Jan, just for anybody out there who doesn't know what a Git commit is, it's a way of saving your progress so that you can roll back easily. That's, I think, a very succinct way of putting it.
Yeah.
And these notes are to help
These are what I write on each commit. So every time I want to save a snapshot of the code in case something goes wrong and I want to go back to it, which did actually happen in this rate, you write a note so you know where you were. But I was doing like 12 a day. This is kind of tiring. Seriously, how is it not nap time? Stuff. Come on, net data. How about now? Some helpful commit note. More bug fix. A commit message. This is where I start losing the plot. This is 3 days ago. I like lemon sorbet best. And probably marzipan the least.
Comment below which one you like.
Wait, how is the lobby being joined but no connection being made? Well, no, durian fruit is objectively the worst. Yep, definitely one of those weeks. I know. Seriously, though, why are you not up here? Revert to commit, push it real good. Let's try this then. This might actually work. Except it didn't. It's slow, but it's progress. Come on, tactics. I really should eat breakfast soon. And shower, of course.
This was at 10:45, so that's well into the morning at that point.
Nope, that didn't work. Time to get breakfast.
Yeah.
Electro swing will work.
Always works.
But not very much. Tentatively hopeful. Resetting back 2 days. Fixing typos. Fixing friend list. Fixing permissions round 1. Round 2. Round 3. Fight! Slowly, catchy monkey.
Oh,
Who wrote this script? So much facepalm. Whoops.
I've had once before on my commits.
I wonder what to make for lunch. I should find out soon. Last try before I fix my blood sugar. And this time I mean it. Honest. Fixing net data some more.
I'll just point out here, this is at 4:30 in the afternoon, so well past lunchtime.
Can't see this working, but who knows? Trying a new approach.
Oh, blimey, it goes on. So
that didn't work.
how are you feeling at the moment, though, about it?
Well, okay, we've made a lot of progress. The
Yep.
lobby now completely works. I need to speed up the updating. Now I'm trying to fix the problems in the game, and we're moving from one net structure to a completely different one that I'm not familiar with.
Yeah.
Is causing lots of issues. I've gotten rid of most of the critical bugs that happen during play. You get a crash when someone leaves, but I'll fix that later. That's not critical. Okay, so trying a new approach. Well, that didn't work. Nor that. Maybe I can stop all those explosions at least. Trying to be sneakier. Getting closer.
Ooh.
Ain't nobody dope as me. I'm just so fresh, so clean. Intergalactic planetary. More bugs to fix. I'm going sailing to outer space.
You went musical.
Another place.
Yeah. You went all musical on it.
Yep. Trying to stop the join lobby crash, which hasn't happened yet. I wonder what this button does. Nothing good. I mean, maybe. Okay, less crashes. Nope, same amount of crashes. La 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 la. My milkshake brings all the boys to the yard. Lydia, oh Lydia, say, have you met Lydia? Lydia the tattooed lady.
Of course.
Yay!
One of the problems is if you do make commit messages like this, you do have a problem if you want to know what it was that you changed.
I have no idea why it's not working, so I can't go back to this commit.
Yeah.
Yay! 2 bugs squished back to back. In your face, Space Coyote. That's a Simpsons reference. 3 bugs. We got the bugs. I mean, there's more, but whatever. That's enough for one Sunday because I'm brain fried. Permission fix. Added lobby timer. Fixing lobby timer.
Hey,
it's going to be a long day, isn't it?
We're back to actual commit notes.
Okay, does it
work? That's a good sign.
Nope. Interesting. So the host is overwriting the server settings. Aha! Got it! All right, let's start the spawn bug. Suddenly we have infinite recursion. This may help. Don't you wish your girlfriend was hot like me? Don't you? That was the last commit, after which I was like, I'm done for the day. I give up. I've had good progress. That's it. That's all you're getting. Nice.
We got a question. Is that a GodotCon t-shirt that you got on?
It is a GodotCon t-shirt. This is one of those. This is the one from when I went to GodotCon 3 years ago, 2 years ago.
I can't remember. Yeah,
before COVID, so 2019, I guess.
Did time happen between?
And I gave a little talk on why you should be making tutorials.
And here we are making tutorials.
Yeah, so I'm exhausted. It is good to see it working. We've actually applied for our Steamworks account.
Yes,
but they didn't believe that we're a company, so we're having to wait for something from the accountant to show that we're real.
Yeah, which is boring admin stuff. But I suppose.
Hey, it's Lucy. Hello, Lucy. Haven't seen you in a while.
So yeah, I'm also sat in a room that's now getting hotter and hotter and hotter. So I may have to. I'm going to be slurping down this water quite.
I've got my water here, but the good news is because this is a Blender week, not a Godot week, I won't have to be on camera a lot of the time. So I can just like turn the fans on full and drink water, and no one's going to notice.
Where's Yang gone?
We don't have to have a company to publish on Steam, but we wanted to go through a company because we don't want to mess around with weird taxes. And if I'm publishing under Canopy, I don't want to then get all the money and say to Mikey, I only made 3 sales this month.
3,000. Sorry, I was drinking water there. So yes, in terms of any other housekeeping, I think we're pretty much set there for the moment. If anybody does have any questions as we're going through the stream, just ask them, and Jan will.
I'll be keeping an eye on the thing.
Yep,
that's my second monitor over there.
Yeah.
I'll also be probably opening a window. So if you hear dogs barking, I'm sorry. My neighbour's dog's very loud.
Woof woof. I've also got a neighbour with a dog, so if they also bark, then there might be multiple dogs.
3.
So well, I will switch over to my screen.
So Michael, I think I know, but what is a geometry node?
Well, let's move over to here. Hello. So we are going to be using Blender 3.2 for this. I was tempted to go and get the alpha version of, is it 3.3? but stability and stuff, I thought best for a stream to just, and we're focusing on basics, not the bleeding edge of stuff, that this would be a great place to start. So geometry nodes came about in 2.93, and it's, I wouldn't say revolutionized, but it's changed the way that you can do quite a few things within Blender, and it's far more optimal for and replaces some of the other things like particle systems as well. So one of the things that you could do, let's say if you wanted grass on the ground and scattering of rocks, is you could generate multiple particle systems, and you could use weight painting. And you could do all of that now in geometry nodes, and because it uses a better instancing system, it's far more performant as well. But it doesn't just stop at that. You can do lots and lots of different things with geometry nodes. Now, what is it? Well, it is a workspace that we can go to, and I'm going to immediately butcher the workspace anyway, so because I don't like it. I prefer a vertical setup, and this is a horizontal setup, and it's very difficult to show flow if you've only got a narrow space to work in. So geometry nodes is a workspace that they give you, and this is the default layout. At the top left, we have something called the spreadsheet, and that's useful for getting data. Because you can inspect certain elements and see what, how many vertices they've got, where they are, faces, and all that lovely stuff. I don't tend to use it as you're playing around to begin with. So I'm going to hide that one out the way, and I'm going to make this a full screen. So this, the Geometry Nodes editor is a node-based system. So you're essentially programming, you're writing some sort of algorithm, but you're doing it visually by using nodes. And I'm going to break out this window here. So we've also got a 3D view as well. And then we can see what's going on. And I've hit space at some point. Right. So when it comes to geometry nodes itself, there's an input and output, and you have to have an object, a reference object in your scene for that to work. And I do believe it has to be a mesh object, and we would usually have a cube in here, but it doesn't really matter what you've got unless you're using that geometry and doing something to it using geometry nodes. And if we have enough time today, I might get to that point. I have no idea about the timing, but as we go, if you guys have any questions, this is going to be almost like a journey of discovery for both of us as we go, because I'm going to deliberately play around and just see what happens. I've got a rough idea of where we want to go. As I say, if you've got any questions, just shout out. Right. So we've got an object in our scene, and we want to use geometry nodes. And there's this new button up here, and we've got our object selected. So we could click that. And as you can see over on the Properties tab, we also have a modifier being added called geometry nodes. So it's a modifier that goes on a mesh object. There you go. Jan, does that clear up some of what a geometry node happens to be? Or do you want to see more about what it can do?
It's a visual... It's a way of visually representing and programming data as opposed to doing it through typing.
Yeah.
So technically, you could do everything you wanted to do by typing coordinates for each vertex and line and face, but you can also do it this way.
Yeah.
A bit like Visual Shader in Godot.
It is very, very similar. In fact, there are some things, there are some similarities between this and the shading workspace. Not only are they nodes, but they actually contain some of the same types of nodes, which is awesome. Now we have a group input, and you'll notice that there are other things that can come out other than the geometry. So at the moment, the only thing coming into our geometry node setup is this cube. So we've got... I really wish I had shut down the spreadsheet now. I'm going to open it up so I can just show you, and then I'm going to hide it out of the way and we won't care about it.
Always the way, isn't it?
Yeah. Well, rather than just saying it, we can reference the stuff on the side here, because that geometry, there's 8 vertices, 1 in each corner. There are 12 edges, 6 faces, and 24 face corners, and there's no curve data or anything along those lines. And then we have an index here, because there are 8 vertices. We count from 0. That's important to remember if you're referencing any index within geometry nodes. But if you've done any programming before, you'll know that you always start counting from 0. And so there are 8 elements in this, I suppose, array of vertices, and it gives their world positions in there. So there's a list of all the vertices. Here's a list, well, not a list of edges, because those are just connections between vertices, but their crease data. Then we've got their face and their normal direction, which is interesting because that means we can either use that normal information or we might be able to manipulate it. I don't think we're going to be getting to manipulating today, but you can do it. And face corners reference a UV map. So that's all very interesting, but let's start doing something a bit more fun with it. So we have geometry in our scene, and we can reference other geometry. So if we've got other objects in our scene, we can do that as well. Or we can make geometry within this node group itself. We don't actually need the geometry that's there in this system whatsoever. So if I go into the geometry nodes and add in, and this is a big long list of everything that's currently here, and so we're not going to go through everyone, don't worry, but there is an area called mesh primitives, and I'm sad that Suzanne doesn't exist in mesh primitives, but we can use, well, let's go get a cylinder, because then we can see what's going on. Cylinder's a bit better than a simple cube because it's got more things to play with.
I was going to suggest a sphere for that very reason, but
cylinder, sphere, also
cylinder, fine.
Now you'll notice here that some of these nodes will actually have inputs to them, and that's really useful because if you want to change the size, or well, let's say you want a cylinder that's a meter tall, and then later on you want to align it with something, and you want it to be aligned with the middle of that cylinder. Then whilst you can go here and say the depth of the cylinder is going to be 2 meters tall, what happens if you want it 3? You don't want to have to come back here and start to change this and then change a transform later on. You can link those things together and have an input coming in that says that the depth is 2 or 3, and then you could use a math node to divide that in 2, hence halfway, and then position something there. So that's what these inputs are mainly for, so you can have more control over how things are constructed and use that data elsewhere. And then we've got mesh data coming out. And if I take this mesh data and just dump it in the group output, our cube just changes to a cylinder. And the great thing about this is we don't have to use this group input at all at this point. We can just go bye-bye. We're going to focus on making geometry completely procedurally. So we've got all of these controls here, and we can go, well, actually, I want it to be a prism. That's what you call this shape, I believe. So we can change all of these as we want. And there's something here called side segments and fill segments. So there are things that you wouldn't necessarily see when you're creating a cylinder itself on the operator panel. You'll see here that vertices, yes, radius and depth is something that you've seen before, but those other options aren't there. And those other options are to give us further detail. I'm going to get rid of that cylinder. There we go. And go back to our generated one. And you won't see any changes if you just scroll these up because we're looking at this in solid view. So to see those changes, if we actually look at the wireframe, we can see what that's actually doing. So side segments, as you can see, is almost like putting loop cuts, cutting our geometry up around its circumference. That's the word. I'm going to mince my words at some point today. And then we've got the fill segments, which, as you can see at the top here, hopefully this is coming across with the YouTube compression okay. But you can see here it's cutting around the other way, radially. I think that'd be the right word.
We'll go with radially.
Yes. So I'm going to get rid of this and link back in my cube for a moment. Because one of the things that we deal with a lot when it comes to geometry node is something called a point. Now, points are simply, well, I suppose, vertices. They can be considered as a vertex, a point in space that you can use to do something else. So in this instance, we can show all of our geometry. Hit the right key, Mike. There we go, solid mode. So we can show our geometry by having the group input come in. But say instead of having this cube show, let's have a cylinder appear where each of the vertices of our cube is. So we should end up with 8 new cylinders placed around. And this is just playing at the moment. There's no end goal at the moment. It's really just to show how things link together. So we've got a mesh, which could also be something else that you've created. I'll show you that in a moment. And we need to instance this cylinder on the points of this geometry. So we're going to instance on points. So instances instance on points. Now, I'm going to try and go through the menu, but I'm so used to going Shift and A and just using the search menu to find stuff that I don't know where everything's hidden. And of course, you can start typing in instance. You can see there's lots of things you can do with instances, and instance on points is the one we want. So what does this node do for us? Well, we're going to take a series of points, and we know that the points that we want are the ones on this cube. So let's go ahead and say we want the points there, and everything else disappears. And then we're going to do something with these instances coming out. Well, let's show them. Still nothing there because we've not decided what that instance is. Now, you'll notice here I'm skipping over what all of these other things are. Some of them are self-explanatory. Some of them we probably won't get to cover today. But they're all really, really useful. I'm hoping we're going to get to the point where we can do the selection today, because that's a Boolean to say what areas do we want, what areas do we not want. Now, before I actually instance these cylinders, I don't want them to be this big. I'm going to make them a lot smaller, something along those lines, I think. And I'm going to link in the mesh to instance. And I'm going to make this full screen for a moment so we can see what's going on. We have a cube that we can't see anymore. It's gone. It won't be there if we render it, etc. And what we've done is we've instanced that cylinder that we've programmatically or parametrically made. It's a procedural model at this point. And we've taken in the data of the cube, and we've said for each of the points, we want a cylinder of this specification. And there you go. That's on there. You can already see that this could be incredibly useful if you wanted to have a cube in your scene, and on each corner of the cube have an item or an element. Or perhaps you weren't doing that. Perhaps you were making a building and you wanted each corner to have a pillar or something along those lines. You can see how this starts to come together, and you can get a very complex setup from a simple set of rules. In fact, what happens if we go into edit mode on this object? Oh, we can see our cube again. That's useful. If I select this face here and extrude and just pull it along and grab this one here and extrude it along this way, we can see now we've got these at various points. So if they were detailing on something that you wanted to build up, and obviously this is quite restrictive at the moment because we're just instancing on every vertex this element.
Inset and bevel. Inset and bevel.
That'll create a load of... okay, to humour Jan, inset.
Sorry, if you're going to extrude, you have to inset and bevel. Those
inset.
are the rules.
There you go. So by beveling, we are literally editing geometry here. By beveling, we are creating significantly more geometry. And I don't know, is this the beginning of the Giant's Causeway over in Ireland?
It could be.
Wait a minute, have we got enough sides? I don't know what they are. Are they hexagons or no? I don't know.
Octagons.
Are they octagons?
Pretty sure, because they're basalt.
There we go.
Which is a fun word. You should just shout basalt a lot.
So we've got our cylinder over here. So we can see one of the great things of geometry nodes is because it's parametric control, we're controlling these parameters over here. I'm just going to lower some of these down so we don't have too much geometry. But I can come in and set it down to the minimum of 3, and everything changes. Everything updates that we had before. And I hope at that point you can go, oh, that's really useful. That's like I've linked duplicated all this information elsewhere, and then I can change it around. But we're changing something that you can't usually change later on. Just to go back to the example I had earlier, when you create a mesh object, at this point, we've got these options to change its parameters. But if you go away and do any other operation, you can't go back and change those parameters anymore. You can't say, well, I want it to be have extra resolution. You can kind of do that if you start altering the mesh geometry, and if adding a subsurf would work to it. But you're stuck, really, with the geometry that you have. So this is where having this geometry node set up can be incredibly powerful. Now, do we have any questions so far?
Not so far. So don't forget, if you do have questions or concerns or opinions or things, type them in. I'll shout them out, Mikey.
So one of the ways that I've used geometry loads, not lots at the moment, is to create a grid-like structure for making something like buildings. And if you can bear with me a few moments, I just want to show you one of the great uses of it. And this is a very scratching the surface, and I hope it works in Blender 3. I don't think it. Yes, it does. Yes. Hold on a moment while I go and find something. I'll save where we are at the moment. I'll put this as live stream. Yeah, capitalization like that is absolutely fun. Right. So I was working on a thing with Holistic Games a while back where we were creating assets and sticking them together, and we were using geometry nodes in order to do that. So if you bear with me a moment, I'll go find the actual files themselves, and then if anybody does have any questions, I can answer them after I've loaded this up. So what would you use geometry nodes so far, even though you've only seen just the very beginning of what's possible with it?
I mean, it feels like an easy way to load in some extra details and so on. But I'm thinking if there's ways you can choose or alter the amount of vertex per instance, then you can start getting some really interesting little details, or possibly you've got various booleans you're going to bring in to
Yes.
intersect your shape, and you could change the ones they are. So rather than having to go and make them all manually, you pick them and programmatically put them in. So suddenly, greebles.
Yes, you could. The challenging thing with geometry nodes is finding the right algorithm. And like most things in my experience personally, you have to be comfortable with deleting stuff and just starting again.
Yep.
Because sometimes you have an idea, you start planning it out, you're essentially sketching it, but using the nodes. And then you get to this position where you're not quite in the right place. You're almost there, but you need to change the way things are structured. Now, sometimes if you've been quite methodical going through and you've grouped things together to create your own little node groups that do stuff, then it's great because you can just use those node groups and rebuild and work it out from there. But if you haven't, then it can end up a big spaghetti mess. And as you can imagine, this is only just 2 nodes, but node trees can end up getting absolutely massive for complex scenes. I think I found the one that I want.
Now, is there a random node?
A random node? Yes, there is.
Okay, so you could do like a random integer within a range and start doing it that way.
So I've just brought this out because there's absolutely no way in an hour that we could create something like this. But what we have here is a series of individual components. So whether it's a window or whether it's a door piece or a blank wall piece, and they're being instanced on our scene. Now, if we go down to the modifier itself and make sure we've got the right thing selected, I haven't. There we go. This is the actual geometry nodes. You can see here where I was talking about you can pass in input parameters, not just geometry itself, but input parameters. We can come in now and we can say, well, this building that we have, why don't we make it a little wider? And you could just make it wider. Now, I've capped the limit here. I've said, well, this can only be between 2 and 8. And that just saves accidentally dragging it too far and ending up with too much geometry. And we can change the depth of it as well. And similarly, it's locked to a certain size. So we can have a really skinny building. And then we control the midsection height and the ground floor height. So we can have multiple instances of ground floor. But you won't find a door on the second part of the ground floor, if that makes sense.
We've got a comment from Salary Cat, which is a great name. That's the problem with GeoNodes. They don't allow too much flexibility on describing what you want to do, unlike programming. I think that's probably true in most kinds of visual programming. I certainly found it when I tried to use visual script in Godot, was it's actually easier for me to type it because I'm having to translate what I would type into a node to put it back. It's something like this, though. If you can use a random integer, I could see a case where you could have different kinds of windows for each building, or different kinds of material, or different detailing over the doors, and just select which rules you're going to be using on a roll of a dice.
So one of the things, and I'll get back to that, what Salary Cat's just mentioned there in a moment, but you were mentioning about random things, and I do want to state at this point, before we get too deep into this, that when it comes to making things procedurally, it's not, and we've talked about proceduralness lots on this channel, but you have to be careful that you're not the tail wagging the dog, because you can very easily end up spending hours and hours creating an asset using geometry nodes that you could have created 5 different assets just with standard modeling.
Yeah, it's one of those things where this is a great tool if you're using it for specific reasons. So what's your reason for using the tool? If it's just, this is shiny, that's a good way to learn. It's not a good way to produce.
Yeah, definitely. And that there are examples of models that definitely benefit from procedural modeling. So the example there where I've got a block of flats, you could create a very varied city with only, and you do have to make the models anyway and arrange them, but then you're using geometry nodes as an automatic assembler. You're not relying on it to actually create the underlying geometry, which you can do. I could have made that block of flats purely by using these nodes in order to construct geometry, both additive and subtractive and other manipulations. Subtractive being using booleans to cut things out, like a hole for a window to go in.
Here's a question for you. You say it has to be a mesh. Does that include things like metaballs?
I'm going to say no. Because
if you could, that'd be a great way to make random clouds really quickly.
Well, you could probably create the random clouds by distorting a sphere, like an icosphere, and distorting it in geometry nodes. But it's not a mesh. It's not mesh data. No. It's a separate type of object, and it will have its own separate type of modifiers, if indeed it accepts modifiers.
But it does have text. Wait, there's metaball right there. Yeah.
So it doesn't have any geometry nodes association with it at the moment.
You have to convert it to a mesh.
Yes, at which point you lose the fundamental.
Yes, just use it. Yeah.
the point of having a metaball. Yeah, exactly. So to circle back now onto Salary Cat's thing with the problem with geometry nodes is they don't allow much flexibility in describing what you want to do. I'm going to say that's only partially true. And the reason why I say that is because what you can do is group things together and give them basically creating your own functions within geometry nodes themselves. There's no looping function at the moment, which is highly requested, do this 5 times. At the moment, you'd have to basically make it a node group and then repeat that node group, which is just a collection of nodes, as the name suggests. Just repeat it 5 times, which is a bit annoying. But it is something that we have to do at the moment.
Salary Cat has mentioned that in 3.3 they've added a volumetric cube, which could probably be used a bit like metaballs. I did not know that. That's a lot of fun.
Yes, and of course, if and at any point you could do a conversion to a volume, I believe. I don't know if this exists. It might not. It might in 3.3. So if we did something like mesh to, well, we've got volume to mesh. Perhaps in 3.3 they've got mesh to volume. So you can take various types of data and convert them.
Well, if they have volume to mesh, wouldn't that include a metaball?
No.
Is that not a volume?
No. Okay. Not within Blender's data structure anyway.
You can see this is not my wheelhouse.
But it can be very very challenging to try and work out what affects what, and obviously this is all new as well. They did a huge overhaul with Blender nodes like 6 months ago. A lot of the nodes
they released them. Yeah.
Yes, they figured out there's a better way of doing it. They're not going to change too much. It's more adding stuff at this point. But let's take our cube that we've got here for a moment and go to the control that has been mentioned before. So I'm going to link these two together for a moment, and that's no longer a cube. I'm going to create a cube, and I'm going to give it the geometry nodes that we had before, and all being well, nope. Okay, let's go down here, add a modifier. Geometry nodes is under generate, and then we can select our geometry nodes again. Okay, so we've got our cube coming in. Now, let's say we wanted to do something to just the top or just the sides or just the bottom. Now, if you're generating mesh data by itself, you could just generate a plane and do stuff to that and then move on from there. But if you're importing geometry from a real object and performing operations on that, then that's not so straightforward. At that point, we need to start doing some more funky stuff. We need to separate out geometry, and we need to talk about things maybe like normals in order to get the faces that face a certain direction. And I think actually this is a great time to do a bit of fundamental stuff before we go back into geometry nodes about what happens with normals. Now, this sounds like a very odd thing to cover at the moment, but it helps when you need to conceptualize the maths involved. So if I go and add in a new object, because I'm going to be deleting and moving things around, we've got a basic cube, and everybody knows what a cube looks like. And if I said, what do the normals of these faces, or where do they point? They're going to point along the X, the Y, and the Z axis whilst the cube's at this orientation. So we're going to have a vertex, a normal facing straight up from here. So that's talking about the face. And I made a discovery myself whilst playing around with this, because I was curious as to, okay, so I know what a face normal is. How's an edge normal calculated, and how is a vertex normal calculated? Because ultimately these things are averages of one another. And so if we go to our overlays, is it on overlays? I can't remember where it is. It's been a while since. Oh, I need to be in edit mode. Okay, go into edit mode and go to your overlays drop down. Scroll all the way down, and we can turn on vertex normals, edge normals, and face normals, and we can grow them out like so. So we've got these, I hope these show up on stream. We've got these cyan, I'm going to call them cyan. They are our face normals. You can see that they stick out the faces of our object. And we've got these blue normals here, which represent our vertex normals. And this edge here is simply an average of vertex normals of this vertex, and the other ones attached. You can see here it's bent towards the positive X direction. And if we look at it from this side, they're both bent out on the Y direction. So you see they're being skewed. And they're being skewed from these other faces that are attached. So if I went and deleted those faces, you can now see that Y direction that they were being influenced by these side bits has gone completely. They're now straight on. So we're actually manipulating these normals by how they're connected together. If I get rid of these two sides, so we're just left with the top and bottom, suddenly all of these align with one another, because these vertex normals on the edge, they're not being bent by anything anymore. And interestingly, I think, and this is a guess here, I think the type of shading you have will affect these normals.
I was about to ask, how does this work with things like smooth face?
So we were actually talking about this the other day. I can't remember if it was on a stream a while back, but when we're flat shading, we've got a normal going up, a normal going out, and a normal going out this way. You need those 3 extra normals per face or per vertex of a face in order to make it flat, so it's flat shaded. Now, what I'm hoping is if I shade smooth, perfect. Look at that. We've lost those extra ones, and now we've got the average. And that describes how the normal is going around. Essentially, this is almost trying to render a lumpy sphere very, very badly. It always looks ugly with this type of shading. But this is why these normal, the overlays for the normals actually exist. It's very, very rare that you end up using them. But what you can do is if you've got a shading problem on your model, you can look at this and see what the underlying problem might be, because you can see which way those normals are pointing, and you can start to manipulate them.
It also now makes sense what weighted normals are and why they make the model look good.
Yes.
They take faces where there aren't enough normal information to draw a good average and just weight them.
You need to turn on normals down here to do it, and you can see at that point it has changed. Well, it's not actually changed its shading yet, but it has added our normals back in by putting on auto smooth. And I'm not sure whether it's actually going to update.
Now try keep sharp on the weighted modifier.
Yes, so it's not going to affect our normal overlay because what we're doing is we're modifying the geometry. That's not the real geometry. The real geometry, doesn't have has been affected by this normal setting down here. But when we go here, it's not going to change any because this is just a modifier applied to it, which is, I suppose, a shame. And I presume that the same applies if we try and add a subsurface modifier to it. This is a great example. Our normals still don't change because we're talking about the original object.
So you'd have to apply it and see how it looks.
Exactly, which kind of defeats the point of having the modifier at that point. So there's a little dive into normals, but there is one that I didn't describe, and this one actually caught me by surprise because I was like, okay, so if you've got a vertex, what is a vertex normal? How can a point somewhere? That makes no sense to me. Surely it points nowhere. And this was, as I say, this was an eye-opener for me. So let's just delete those vertices and that one there. And so when we've got a flat shape like this, you can see that all of the vertices are, they're pointing one direction. That makes sense. If we delete these two here, then we'll end up with just an edge. And I'm like, well, okay, it's kind of pointing out there. And it took me a while to realize, let's delete the last vertex here. How's that got a direction? How on earth is... Oh, it lines up with the world origin. And this was like an aha moment, because as I moved it around and lost it, as I moved it around, I realized, oh, there's something I never realized before, that everything stems, when it's just a vertex, it stems from the world origin itself. And that's useful to know, because if you're putting points on stuff that aren't linked to anything else, they're just points, their normal is going to point towards the world origin, or maybe the object origin.
I was just about to ask, is it the world origin or the object origin?
Let's there you go. If we move it over there, it's pointing towards our object's origin.
Okay.
So, hands up in the chat who didn't know that. Hands up in the chat who didn't care about that, and they want to get back to geometry nodes.
Yeah, of course you can't type if your hands are up, but put your hands up.
No, that's why I wanted to put their hands up. All right, let's get rid of that cube and go back to our playroom. So this is how I tend to work when it comes to geometry nodes. In fact, sometimes, because I'm not, in fact, I'll go to my true. I'm very rarely do I need to access the outliner. So why not make that the 3D viewport? Because that's a nice small space at the top. And usually what you're making kind of fits into that type of area. And if we need it big, we can go control and space and just make it full screen if we need to have a closer look at stuff. All right, let me have a drink. I want to have a look at separating things out. As I was mentioning before, one of the ways that you can construct an object is to make it as simple as possible. So if you're going to put something on top and you're using geometry nodes to create everything, well, just create the thing on top. Don't try and create the whole object and then separate things out. But if you were doing a building generator, you might want this cube, for instance, to be the basic shape of the building that you're working on. So you might want an L-shaped building, and you then might want to duplicate that and make a cross building, or just an elongated building. There are lots of options, and then you can use your geometry nodes in a much more versatile manner, where it is adding geometry or manipulating geometry that already exists. So let's take our cube here, and let's say we want to add something, but add it only to the bottom or the top. How do we go ahead and do that? Well, intuitively, you might say, well, I want to add geometry to where the vertex down here, where the normals are pointing down. We've already seen that with our cube, when we had all the normals on it, that we've got some normals pointing up and some normals pointed down. We can use that information. And this is where things start to get a bit fun, because we need to use a dot product in order to So this is one of the things when it comes to using maths. This is a very intuitive way of using maths once you understand some of the basics, and that's why I was showing you the normal stuff earlier, because if you are using normal information or even positional information, you need to understand a little bit about how it all interacts with one another. So I'm going to take this off at the moment, so we end up with a... no, I'll leave it on so we can see it as it progresses. Some of the things we won't be able to see initially, but we can play around and show them. And before we actually jump in and start playing with these nodes, if you are following along or watching this back later and have got this far through, thanks for staying with us, we have under Preferences an add-on called Node Wrangler. It is like, just turn it on. It's so important. It makes life so much easier when you're dealing with nodes, whether you're in the shading workspace or you're in geometry nodes. It enables some very simple things, and I don't even use it to its full potential. But little things like you've seen me already plugging and unplugging things, but I could have just held down Control and right-clicked and dragged to delete that. I believe, I can't remember how to join things together now. My mind has gone blank. But one of the other things that you can do, which is incredibly useful, it saves you having to relink lots of things later on, is you can hold down Shift and slice through, and it will add this little socket point or a joint that we can use, which is awesome if you need to branch out from one position and perhaps change something on either side of it. I found having the ability to do that saves so much time when it comes to recreating or changing around geometry nodes.
Roderick wants to know if you've tried unplugging it and plugging it back in again.
What, my brain? Yeah, I tried a nap earlier. So there is that. So we need to do a little bit of maths here, and we're going to do a separate geometry because that's what we want to do. We want to separate a bit of geometry from here and play around with it. So let's go and add in a separate geometry node. I don't know where this is, so I'm going to search for it. So if we go here, separate geometry. So this is going to take some geometric data coming in, so our cube, and it's going to pass out a selection. And we've got a couple of options here. I'll delete this floating point for a moment. We could pass out the selection, or we could pass out the opposite of the selection, which is great. Let's say if we've got the top selected and then we want the rest of the model selected, well, that's what the inverted would be. And then we've got an option here. What do you want to separate? In this case, we're going to manipulate a bit of face data so we can say face. Now this is where the selection comes in. What we have here with the selection, if we hover over it, anything that's pink and diamond is a Boolean. So you're going to have to plug something in that's either going to return 0, which means false, or another value, because that would be true. In this case, usually it's 1. So we're going to plug in a comparison node. Now, one of the great things is you don't have to add nodes and connect them anymore. As of 3.2, I think, it might be 3.1. I can't remember, but you probably notice as I've been clicking, this little plus appears. So we can actually add in a node straight away. And I'm going to type in compare. And we have compare, and it has a load of lists or a load of sockets or options. And this is all the same node. It's just got different options selected. I want to make sure this is separated by less than or greater than. I can't remember. We can play around with it in a bit. So we can plug in a value like that, and then we can basically plug 2 additional values in here and assess them. And if it turns out to be true, we've got 1 result. If it turns out to be 0 or false, then it won't be selected. And you'll notice here, the moment I created this and plugged it into the selection, we've got our geometry disappearing. So we've got an integer here. Is A 0 greater than B 0? Well, no. But is 1 greater than 0? And our cube appears. So rather than the whole object, we need to give it some extra information. So we need to take in some input data. And we're going to use the normals. So this puzzled me the first time I ever used geometry nodes. I was sat here going, normal of what? Normal of what? And it's the normal of the vertices, the points that we're using. So this is going to apply to every single point that's within our geometry that we're using. So in many ways, what is happening is when we get to this stage here and we've got our separate geometry, this selection almost works backwards because it's dependent on whatever this geometry input actually is. And that can be very confusing to wrap your head around to begin with, because you're working backwards down this chain rather than saying exactly what it is. If we hover over this, I believe it will say it's not been calculated yet. Yes. And it can't be calculated yet because it doesn't know what geometry you're actually wanting this normal data for. It needs to work backwards for that. In fact, I don't think we need this greater than. I will leave it there for a moment, but we might not actually need the greater than, because when you do a dot product, you end up with a value coming out, a scalar value coming out. And we can just say, I think if it's 1 or 0, we will get the value out that we want. But let's play with it and see. So we need a vector math node. So add vector math. And then we get scariness. Vector maths is not my strong point. And I really want to sort of hone in on the fact that you don't have to understand the underlying maths if you know what the thing does. Understanding it gives you much more breadth in what you can do. But if you know, if I take the dot product of this, I'm going to get that, then you could just use it intuitively like that. You don't actually have to understand the nuts and bolts of what's going on underneath. To create more complex scenes, I'm gonna throw it out there that I'm afraid you do need to understand that maths. But to do some basic operations, you can just use this. So we're going to take the normal data, plug it in, and we're going to do a dot product, which is just down here. And then we've got our own vectors that we can control. And then what I can do, because it has a single value coming out, I'm just going to try and hack this at this point in time. This will probably give us more control. But if I plug this in, what we're doing here is we're comparing all of the actual geometry to 0. So if I put in here -1 or 1, yeah, I guess right. So again, I'm playing. I want to make sure that you guys are aware of this is one of the best ways of learning is how do I find out what works? Seriously, plugging things in, Googling it, etc. is all a great way of trying to work out how to do a certain thing. And by playing around like this, you can start to get a vocabulary that actually means you can ask better questions. So now that we've plugged this in, I think if I'd plugged this in the bottom and I'd also said 1, we get the same result. This is not something that it matters which way round it goes in because it's a dot product. And so we've got this coming in. And what we're saying here is anything with a value of 1 on the Z direction. I almost said Y. I've been playing in game engines too much. Naughty, I need to come back. So anything that's pointing up, how similar is it? And we get the answer. Oh, great. This is the top one. Now, how do you think you get the bottom one, Jan?
I would say that you would have to get the -1.
Okay, so you can see here how we can potentially separate out X, Y, and Z. And this is where you can end up with a lot of... you end up with a lot of nodes on your screen to do all the separation. So you can be somewhat clever about it, or you can end up being just dumping a load of nodes on the scene on the screen. Now, what you generally end up with is, and most things I fully put forward that if it works, it works. You've done the job that it needs to do, even if it's not as performant as it might be. As you but geometry nodes itself is really, really performance. So you're going to struggle unless you do something really silly to actually have Blender crashing. I mean, if you try and instance 1 billion points on the scene, it would probably handle it, but it would depend on how strong your computer was. So we can actually change these values. We can put a positive. Notice the little gimbal at the top here. I'm going to turn it around the other way, so Y is facing to the right. So now we've put positive Y in there. In fact, we can have any positive number. We end up selecting the face pointing in the positive Y direction, the negative Y direction. But look at that. If you add in, you can get corners of buildings and maybe the corner and the roof, which is incredibly useful. And if we wanted the rest of what was there inverted, there you go. We've got the other side. And where this comes in sort of real use is, say we wanted to separate out the roof, which is this selection here. We've got the roof there. This inverted, we can then do a similar thing with and separate out more from that. So what you could do here, going back to, I forget the name, where we're talking about you don't have much control. We've just created our own little function that separates out this top bit of geometry. Now, we should really test this and see how it affects multiple bits of geometry. So what happens if I extrude this out and extrude this up? Okay, it does only seem to select or give us the very top bit of our geometry, which is incredibly useful because now we've got a way of selecting the roof. Now, I wonder, and this is a genuine wonder because I've not practiced this, what happens if you create... so it even caters for a roof that is pointing upwards. I'm going to guess that if we have a sloped roof, it might not be. So as long as it's pointing upwards, it should still be fine. It's when it points in a negative direction, it won't be. So there we go. We've actually managed to separate out all of the roof components of a potential building that we're creating, which is pretty awesome. So we've made something here, even though it's simple. I'm going to get rid of this greater than. We've made something here with these 3 nodes where we're taking the normal, we're doing a dot product, and perhaps we want to use this information later on so our node is more versatile, so it doesn't just do one thing. And then we've got this separate out geometry. What we can do is we can select these 3 nodes which do that, and I'm going to go Control and G and make it into its own group. So we have here a node group that we can do called select face, or at the moment it does one thing. We should probably call it select roof. But what we could also do is pass out, and this is the same in shader nodes as well. You do the exact same thing if you've made a group. We can actually put all of these outside, so we've got some control. So let's come out. We've now got these here, so we can change these on the fly. So this node group will do, well, we can make it do the bottom by typing in -1 here. We now have all the bottom of our model. And if we wanted to join things together, so we had the top and the bottom selected, well, we can duplicate this node group with Shift and D. We can change this one to 1. We'd need to pass in the geometry, and this is where Node Wrangler can come in very useful. I'm going to hold down Shift and cut, and there we go. We can put it in like this, and now it means that we can change this for other stuff coming in, and we don't have to relink all of these. If we had like 7 of them or 100 of them, that would be a real pain to try and do. And so now how do we join these things together? Well, fortunately, if we search for the word join, we get our join geometry node. And we can plug all of that together. And now we've got both the top and the bottom faces all selected, which is pretty awesome. And now we can start to do things. So for instance, we have here, this represents the bottom. No, that represents the top. This is the bottom over here. Right. I'm going to get rid of the top for a moment so we can just focus on the bottom. In fact, there's a more sensible way of doing that. You can mute things, which is incredibly useful. So muting that actually passes everything through, which is actually unintended. So I'm going to unplug that so it's out of the way. Yeah, there we go. Right, I want to do something, as I was saying, like pillars on the corners here. We can actually use this node group with its selection of geometry to spawn new geometry in. Now, we could actually use a model of a nice pillar, or what we can do is we can go ahead and use a mesh primitive and use a cube. And we can adjust these parameters. I'm not going to adjust them yet because I don't know what it will look like. But I can go Shift and A and do what we were doing earlier, which is instancing on points. And then we're going to join it back up at the very end. And we're going to take the points of the bottom and instance a cube on all of those points, like so. So now we have, well, it's not a pillar yet, but we do have it being instanced in a certain place. Now I'm going to make this a bit narrower, maybe 30 centimeters, and make it, a cube is like, I don't know, I'm going to make it 2 meters high. We've got no control input coming in for this at the moment, because we don't have any information passing through that gives us a good way of linking the two together. However, what we can do now is move this. We can move it so it's up. And actually, this is a great example of what I was talking about really early on. So we've got this size here. I'm going to take that out, and I'm going to create a separate X, Y, or a combine X, Y, Z. So now we won't see anything, but now we can type in, what did I choose before? 0.2, 0.2, and 2. We've now got this control, which means we can do an offset by the half I was talking about earlier. So we need to transform our geometry, and transforming is moving, scaling, and rotating. So I'm going to add in search for transform. Okay, excellent. So when we've got a transform node, we can pass those instances, all of these pillars that we've created. Let's zoom in a little so we can see what's going on there. And we're going to pass it in all the way up there. We're going to remove that instance there. Otherwise, we've basically got duplicate geometry coming in. And we can move this, and we can grab this translation and pull it up. And we need to pull it up half of whatever this Z amount is. So if we take this out, because there's a vector, there's 3 numbers there, its width, its depth, and its height. And if we go ahead and separate it, then we've got this Z component here. That's the only one we actually care about. And we do something to it with a math node. And I'm going to, where's multiply? I could divide. There it is. Why is this? What order is this in? That's in a funny order. I wish that was in... can I actually do multiply? Do they allow that? Yes, you can. Brilliant. So multiply by half. Now, the reason why I'm multiplying by half instead of dividing by 2 is because dividing by 2 is more computationally heavy than multiplying by half. And finally, because we're plugging this back into a translation, which is this purple socket, which means it's a vector, we can't just plug that in. Otherwise, it's going to do it half on all of those directions. It will just fill in each one of those fields with half. So what we can do instead is we then recombine it, which does seem silly when you're doing stuff like this. So combine X, Y, Z, and we're just going to pick Z because the option is there. You could just click it and relink it if you needed to. But what we've now got is all of these pillars existing bang on the bottom of all of our model. And what we don't have at the moment is, an appreciation of the rest of the model. So perhaps down here we can go into this node group where we've got the selection coming out. We should probably have the inverted coming out as well so that we can link things back, or later on perhaps pass this inverted as the geometry that's left over into another node group, a reciprocal function. But now what we can do is we can take that inverted and join it all back together again. And we've got our entire building starting to come together, which is pretty awesome. Now, obviously, I've had no forethought here into heights, etc., that I was extruding by earlier on. And that would be something that you would have to think about really carefully before you started going on a project like this. If I'm going to add pillars on, well, perhaps instead of just guessing the height, perhaps I need to get the distance between this vertex and this vertex to make sure that the height of it is, well, is the height of this edge. I don't know how to do that at the moment. I've been playing around lots with maths, but I'm not going to try on stream.
That's looking very cool. As we've just gone past the hour, if
Have
anyone's
we?
got any
Wow.
questions,
Okay.
concerns, thoughts, interpretive dances, jingles, jams, and jellies, now's the time.
Oh, that's nice.
Yeah, no, that one flew by.
What? Wow. Yeah. Whilst we're waiting for any questions coming in, I'm going to do one more thing for you.
Do you think?
I'm going to put Windows in.
I use Linux.
Now,
thank you. I'm here all week.
Bear with me a moment. So when it comes to, well, I take a deep breath.
Hey, I'm in my 40s. I'm allowed to do dad jokes. Mid-40s, mind you.
I'm a dad. I get to do dad jokes.
Yeah, well, don't you come over all breeder privilege on me.
Breeder privilege. I don't have any response. I can't have any response to that.
So my lungs hurt because I've strained my back from all this coding. So when I make myself laugh, it hurts. So karma.
Oh dear. Right. So we have inverted coming out, don't we? Just here. So that's everything, if I remember correctly. I've zoomed in on the wrong window. Let's just pull that across so we've got more space to work. I just want the walls, the outside walls. And I don't know if this is going to work well, but we're just going to give it a go and see what happens. And then we'll wrap up the stream and I'll answer any questions that we've got. So we've got this inverted coming out, and I want to focus on what that inverted is. So I'm going to hold down Control, Shift, and click. And we're going to hopefully see what's going on. No. They haven't implemented that yet. Maybe, unless I'm doing the wrong combination of keys. Right, so let's just unplug. So we've got three things coming in. We've got our pillars. I'm just going to remove them for the moment, and we can add them back in later. In fact, I'm going to do a tiny bit of organizing. I'm going to select those, press P, not P, F. I'm thinking, oh my word. Okay, I'm breaking down at this point.
It was going so well.
It was. I can't remember how to create a panel. My mind's gone blank.
I think you get a plane and some nails.
Maybe I'm gonna dump them in a group and just move it out of the way for a moment, and we'll come back to that in a bit. Let's just pretend that didn't happen. Right. So we have here the inverted coming out, and that's what we're seeing here. Let's take everything else. So the selection was the roof, and then we've got everything that's left, which is inverted. So if we take the inverted and then add it to what was our node group? We called it node group, which wasn't great. So let's add in group, node group. Add that in there. We can see we've got 3 instances of that at the moment. I'm going to pass the inverted into it and then go and remove the floors. So -1. Now, if we have a look at the selection, it should just be the walls if that has passed through correctly. We've got selection and inverted coming out. So we're taking the inverted. That's everything else but the bottom. Oh, we need to take the roof off. My bad. To take the roof off and then take the selection that's left. So that's the roof. We want the inverted. Unplug the roof. Okay, so now we've got all of the walls of our building selected. Now we can just add windows to them. So this inverted here, we are going to face something. Let me just have a look at what the node is called. We want to use a mesh primitive and use a cube, because that's the thing we're going to use to cut out. Now, bearing in mind we've not planned this, so it's going to have to be like maybe a small tool window or something along those lines, but not too tall, because it's going to apply to all of these faces. We could maybe use a face area to minimize it. I'm going to go for 0.5 for the moment. This is the size of the cube. And what we're going to do is we're going to use that cube to do a Boolean cut to all of these pieces. So we're also going to need a Boolean. So let's go ahead and add in Boolean, and we need a mesh Boolean. We're going to take our source mesh, and then we're going to have cuts. And you can see here, we've got multiple cuts that we can use. So these node sockets here that are elongated, they can take multiple values, as you've seen me use with the join geometry, which is really useful because you can cut out multiple things from here. And if we just go ahead and put this in, it's not going to do anything, because what's happening is this cube that we're using is being instanced here in the middle of the scene, and we need it placed elsewhere. We need it placed where the faces are. So we need to find those faces.
There they are.
So we need to move this mesh that we've got here, this cube that we're generating, we need to move it to somewhere. And that somewhere is going to be a point that's derived from this inverted. So let's bring this out, and we want mesh to points. Mesh to points. There we go. And from here, we can separate it out into just its individual points, which it would have done by default. So we're not going to do that. But what we're going to use is faces. So now our faces are going to have a series of points on them. What we can do with those points is instance this cube on those points. So let's come out and type in instance to get our instance on points. Plug that in. And then finally, what we need to do is use this cube as an instance, and we should end up with a series of holes across our model, which we do. Hey.
And the fonts for some reason.
Hey.
Yeah.
So the final thing here to just wrap up is find where our roof was, which I think is just this selection here, isn't it? And join that back on. Okay, there we go. There's our roof back on. And finally, we've got our bottom, which I just shoved into this node group down here. In fact, if I have, and I apologize for not naming things as we've gone through, slap on the wrists for that. Do as I say, not as I do. And then plug in that as well. We've now got, why is that offset? I'm not sure. If I twiddled a value some point, there's an offset going on here that I'm going to have to find what I've done. Why is that being off? Oh, look at that. When I was faffing around earlier and trying to frame it, I've plugged it into the X as well. So if I undo that, yeah, everything's back to how it is. So here we go. Here's a semi-procedural building. And
I mean, it is procedural. It was made by procedures.
Yes. That needs a bit of work, but hopefully you can see some of the power of geometry nodes there. And
we do actually have some comments on it. Mark says, as someone that always thought nodes were cool but never understood them, this is awesome to learn about. And Render says, so cool.
Awesome. I wish it was so cool in this room. Oh, man, when we started the stream, the room was at 21 degrees. It's now 25 and rising. Yes.
Now, there may be people out there who don't live in the UK are going 25 centigrade. Let me look that up. What's wrong with people in Britain? That's cold. Our architecture is designed to keep you hot, not to let heat escape. So when it gets hot inside, it gets really hot really fast.
So that's 77 Fahrenheit. Also, the UK is humid, which is
only this week. Oh my goodness.
Yeah, it's been absolutely bonkers
at one point. Yeah.
The humidity at the moment, I think I'm going to have a look at what the humidity is, because I'm kind of sad like that. It was like 65% humidity at the moment, and water will condense at 10 degrees, which is a bit nuts. And that's the weather for today. Back over to you in the studio.
Thank you, Tom. Well, it was another great week for the Eagles, which I believe is some sort of sportsing thing.
I didn't think I was doing improv this evening, but here we are.
When I was a theatre history student on one of my midterms, one of the questions I put was, why did the Eagles lose to whatever group that just
Yeah.
wants to. And the options were, they didn't. This is fake news. You can't be serious. Why is this on my midterm? You don't even know who these people are, do you? And I quit. Give me an A.
What was the right answer?
If you answer the question, you got it right.
Everybody wins. A
You
participation
see, I had
prize.
to do multiple choices for midterms, but pedagogically, multiple choice is a terrible way to learn or test. So I would put joke questions in to keep myself entertained. One of them was draw a picture of a cat in the margin. And 25% of the students in my class got that question wrong.
Did you not accept their picture of a cat?
If they didn't draw a picture of a cat or didn't draw in the margin, they didn't get the question right. So one person wrote no. It's like, that's not the answer.
Now, my statistics isn't great, but if you have a multiple choice quiz and there are 4 answers for each question, which is quite typical, don't you statistically it's unlikely that you'll ever get less than 25% if you guessed randomly?
Yep.
Woohoo! Not that that's a pass at any rate. But I remember doing multiple choice questions at school, and I can't remember. It must have been like the SATs or something.
So the problem with multiple choice is they're great from a sort of data entry point of view, right?
Oh yeah.
So in the US under No Child Left Behind, there was a big push to get education systematized so that we could put everyone's scores in and we could see which classes are performing well, which are performing badly, which are the good teachers, which are the bad teachers. The downside is that doesn't actually explain who's teaching well. And there's all kinds of weird stuff that happens when you start judging people like that. Like if you're only looking at improvement, what do you do with a student that comes in with straight A's?
They can't improve.
And the computer tells you that they're failing because they're not improving, and that's the metric. So the teachers get a pay cut, and the student doesn't get to the college they want, and it causes all kinds of problems. But as a result, there was a big push to use multiple choice questions because they're much easier to put into systems. But the downside is multiple choice questions are basically either know something or guess.
I've found when I've answered a multiple choice question, I'm sure you guys have as well, that when you actually read the possible answers,
Yep.
you can actually deduce what the correct answer is by what the others are not, if that makes sense.
Yep.
Which is...
I'm actually going to look up one of the midterms I wrote and going to give you one of the multiple choice questions and see if you do better than my students.
It's worrying that you can still look this stuff up.
I have it all on my Google Drive.
Whilst you're looking that up, so who out there in the audience at the moment has actually played with geometry nodes and gotten somewhere with it so far? And if so, what have you done with geometry nodes? I'd love to hear or even see what you've managed to do. And obviously, seeing will require.
Are you ready?
Discord.
This is question 10 on classical theatre. That's Greek and Roman theatre. Are you ready?
Jupiter.
Which of the following is not considered necessary for Greek tragedy? A, hubris. B, hamartia. C, hummus. D, the protagonist.
I was going to go for herbal tea, but then you said hummus.
Yeah, 25% of my students got that wrong, and I had to tell them afterwards, you're just not reading these.
How have you spelt hummus?
Hummus.
Get out.
That's how you spell hummus.
Oh dear. Yeah, I've had lots of fun with that. There are some. I mean, when it comes to geometry nodes, it's kind of it's given me a reason to learn maths. Like the vector mathematics that I was learning came into so much handy. Just understanding that if something is pointing in the same direction that you're looking at, then it's going to return a value greater than 1, and therefore we can use it as a Boolean operation. We can just say, okay, well, we've got this plane, everything's facing up or down in this case because it's a plane on the bottom. Because those normals are facing down, how do they compare? Oh, we've got a positive value, therefore we can use it and we can use it as a switch and say everything that's got this property, apply this to it.
Thing from Render, you should read.
Played with geometry nodes a bit on my own and enjoyed working through the Canopy procedural weapons course. Yes, covered different content today. Yeah, I wanted to cover this. I was very tempted, but actually, you guys on the YouTube voting thing on the poll, you voted for something else. We could have had this 4 weeks ago, but
Yep.
People voted for textures, which I was actually surprised with. I thought it would have been the other way around. I was expecting textures and geometry nodes to be in the lead, and I was expecting the result to be inverted. So I could have taken the node coming out and used the inverted one. There we go.
Very nice.
Nah, segue.
So yeah, that reminds me. So next week we'll be doing Toucan Talk.
Yes. That'll be good. I was gonna. Okay. So the silence was because I was gonna say, and Jan can show you all of what has been up, but he might not want to, depending on.
I mean, all I've been up to this week is literally transferring API across and trying to understand the Steam API without solid documentation. My life got a lot easier when I found the signal for all peers are connected.
That's a good
Not
signal.
peer has joined, because joining a lobby happens before you are connected to the network.
But joined means you're...
I will get the signal that you've joined the lobby when you attempt to join the lobby. And then once you've joined the lobby, and I can see you in the lobby, and you can see me in the lobby, you're still not an RPC client. So if I send anything through immediately, like you join the lobby, here's the lobby data, will crash. And that took a long time to figure out.
Well, I'd say rather you than me, but we all pick our poison, don't we?
Yeah, I mean, it's worth it. It's coming along nicely.
Yes, the Salary Cat says GeoNodes are lots of fun and ton of useful setups can be created, but it's painful when starting to hit the limitations. Making a good UI for assets isn't mature. Yeah, I think there's going to be a lot of changes over the coming. Probably not with 3, but I think when it starts to become 4. There will start being assets that you can use, that you can drag in and drop, that are procedural generated assets, which will open up a whole scope of things that people can make tools, essentially, like a building creator. At the moment, you'd have to bring in the geometry nodes itself. You'd have to append it rather than asset library it. I don't think this... No, it's not an object. Could we add it to the asset library? Might be able to. Yeah, that's a discussion for another day. And there are features clearly missing, as well as I was saying earlier, looping around something, if and else statements. So you can do. I'm going to use the word janky. You can hack your way around these things, and like loops, you just make a group that you want to do, and you just pass the information continuously through it. But that's not ideal. It'd be much better if you could put everything in a for loop.
But it's still very new in Blender. Like it's come a long way just since it was first introduced. So I have no doubt that it's going to continue improving.
I mean, if you want to see where this sort of thing might be heading, is just check out what some of the things Houdini can do.
I was just thinking that.
Houdini's much more mature from this point of view. It's had a node-based system for ever, as far as as far as I care, or as anybody needs to know. It's had it forever, and I don't think Blender's taking anything away from Houdini. At the moment, it's feeding people who reach the limits of what geometry nodes can do in Blender, and probably jumping to something more proficient at it. Just the same as simulations. You could do rough simulations of fire and smoke and things like that in Blender, and physics simulations. But again, doing physics simulations in Houdini is far quicker, therefore easier. Or using Embergen for making smoke and fire simulations. These, and then exporting them. And what a lot of creators do is they take that data, whether it's a smoke, a destruction simulation, whatever it happens to be, and they re-import it back into Blender and continue working with it. So it's all about using the tools that you're not only familiar with, but you can afford. So Blender's great for being free. You can't hurt it for that. But as Jan was saying, geometry nodes is new, which means that we're in a position where things will change. There is flux. During the weapons course, I recorded a video and I read the release notes for 3.2 or some of the stuff they were working on, and the course is recorded in 3.1. And I recorded the next lecture saying, and in 3.2, you won't have to do this because there's a new node, this one.
I still get messages on the original Discovering Godot course with people saying, actually, in 3.4, you don't have to do any of that. It's like, this is true.
I'm not in 3.4.
No, this was recorded at 3. Well, the original was 3.0.
Yeah.
So
Awesome. I think there would be a good time to wrap up. So thank you, everybody, for joining us this evening. I've had lots of fun.
Thank you for joining us. Michael, thank you for your delicious geometry notes. They were very nice.
Yes. Thank you for timekeeping me, because I think that could have been dangerously like last week's where I just went on and on. But I knew the adding windows wouldn't be too difficult. It worked out all right. So thank you, everybody, for joining us this evening. I've been me. I've
been him. Bye.
See you next week. Bye.
Push it. Push it.
Where's the button?
I don't know.
I don't have the chat loaded. See you, everybody.
Bye.